Hi, how are you doing? Welcome to yet another video, and in this video we'll do another example on differentiation using product rule. We have already done an example which is in a separate video. If you want to check the example, you can check it on the link shown here or in my video description here. You can also find more links to different videos such as Laplace transform, Fourier series, numerical method, complex analysis, and trigonometry if you need to revise in any of those topics. Now let us do another example on product rule. This is from a diploma in electrical engineering past paper. Diploma in electrical ENG year 2022, 2022, not 2020, and it's question 2A part 2, and you are told find dy or derivative of y with respect to x, given that so you have y is equal to x cubed sine squared 4x. The reason why we should apply product rule here is because we have a product of two differentiable functions, x cubed and sine squared 4x. Now, recall the formula. It says if you are given y and you are told to get derivative of y with respect to x, this will be equal to u derivative of v with respect to x plus v derivative of v, not v but u, with respect to x. We can take either of our two functions to be our u, and let us take u, let u to be equal to x cubed, but you can also take u to be equal to sine squared 4x. It give you the same answer. And so if you differentiate this, because we know we need the u somewhere in our formula, let us get it in readiness. Derivative of u with respect to x, this will be 3x squared v, we also let v to be equal to sine squared 4x. You should also note this is a function of a function of a function. We have 4x inside the sine function, and sine function is inside the square function. Because we can also write this as sine 4x squared, can also be written as that. So the 4x is inside the sine function, and sine up function itself is under the square or inside the square. So if we say also, I think I can reduce the let u, I can't use u because we have already used it here in the formula. So maybe let's try something different. Let t equal to 4x, which means v will be equal to sine squared t, and again if we let maybe w be equal to sine t. This, by the way, you can also say it is sine t squared. So w is equal to, if we let w is equal to sine t, that means v will be equal to w squared. Now, derivative of y, not y, derivative of v with respect to x, we will start differentiating from the outermost, which will be v is a function of w, so we differentiate v with respect to w. Then we differentiate the next, which is w is equal to sine of t, meaning w is a function of t. So we get derivative of w with respect to t. And then like 3, we have t is equal to 4x, so we get derivative of t with respect to x. Notice if you cancel dw, dt, you get dv, dx, which is what we want. So that our derivative of v with respect to x is equal to, if you differentiate v with respect to w, that is, this side we are differentiating with respect to w, you get to w. If you differentiate sin t, you get cosine of t, and finally, if you take here we should differentiate with respect to x, t dx, differentiate this side with respect to x, for x to be equal to 4. Which means now if we multiply, this will give us 8w cos t. But what is w? W is sin t. We have sin t cos t. But what is the value of t? The value of t is equal to 4x. So we have this is 8 sin 4x cos 4x. We have dv now, we should substitute everything in this formula. Now dy dx will be equal to u, which is x cubed, derivative of v with respect to x, derivative of v with respect to x, we have just found it. This one, it is 8 sin 4x, cosine of 4x. Here you have a 4x, cosine of 4x. And then finally, we are going to add plus v, which is sine squared 4x, 4x times du dx, which is 3x squared times 3x squared. So do you have any common factors? We can factor out. Common factors are, here you have x squared, here you have x cubed, here you have sine squared 4x, here you have sine x. So we factored out x squared, then inside the bracket we have, here we have an x, 8x. Oh, we should also factor out a sine 4x, x squared sine 4x. This will give us 8x cos 4x plus, we have factored out one term here, plus 3 sine plus 3 sine 4x. So that is it. That's how you should approach that one. I think we have already done enough examples of differentiation using product rule. Actually, this is not one of method that gives student trouble. So we should not invest a lot of our time here. Let us move on and invest our time somewhere else. So I'm going to introduce another method of differentiation, and that method of differentiation is called quotient rule. So I'll remove this now. Now let's discuss another method, which is quotient rule. Used when differentiating or to find the derivative a function that is a ratio of two differentiable functions, Okay, for example, if we have y is equal to maybe example y is equal to 4x squared over sine 2x. 4x itself on its own is differentiable with respect to x. Sine 2x is also differentiable with respect to x. So here you can apply quotient rule. Actually, it doesn't have to be both of them. If this one is also a constant, you can apply quotient rule. Now, so how do you go about this? So if y is equal to u over v, where u is a function of x and also v is another function of x. It doesn't always have to be variable x, but variable x is the most common in mathematics, so that's why we regularly use variable x and variable y. But they could also be any other variable. So if this is the case, then derivative of y with respect to x, you take v there it is, differentiate u with respect to x, then minus u, differentiate v with respect to x, all over v squared. You can also write the formula as y prime. Y prime means y has been differentiated with respect to a certain variable is equal to v u prime minus u v prime all over v squared. So I find this method of noting the formula much easier to remember, but whichever you want to use, they are all the same. I want us to do an example. I have an example here. These are quite a simple example. This is a certificate paper. It is October, November 2021, I think. Certificate electrical. October, November 2021. It's question 4A. 4A. We had already done part 1 and 2 of this question. We had been told to determine ui dx. This is variable y dx given it is part 3. We had already done 1 and 2. Given y is equal to exponential x all over sin x. That's a pretty simple example. We now apply the formula. We know derivative of y with respect to x will be equal to v du dx minus u dv dx all over v squared. Let us take this to be u over v. Let u equal to exponential x. That means derivative of v with respect to x is equal to, if you differentiate exponential x, just remain exponential x. You can check that in your S&P table. Again, if we take v to be sin x, derivative of v with respect to x will be equal to cosine of x. dv dx will be equal to cosine of x. Okay. Let us go ahead. Utilize this space. Now dy dx, just apply substitute the values in the formula. Dy dx will be v is sin x times du dx, which is exponential x, minus again u, which is exponential x, times dv dx. dv dx is cosine of x, all over v squared, v is sin x, so this is sin squared x. If you factor out, what do we factor out now? Exponential x. This is exponential x, sin x, minus cosine of x, all over sin squared, all over sin squared x. So that's how we go about that one. I haven't found any other a little bit complex example on this part, but I think you can set one on for our own. Let us say given y is equal to exponential sin 2x all over root 2x squared over root 2x minus 1 over that root of 2x minus 1. So how can we go about this? Find, we are told find dy dx. Yeah, find dy dx. Now, you know the derivative of y with respect to x will be equal to v du dx minus u dv dx all over v squared. If we take our function now, y is equal to exponential sin 2x all over that root of 2x minus 1. Can say this is u over v. So our u is equal to exponential sin 2x. If you notice, this is a function of a function of a function, because we have 2x inside the sine function inside the exponential function. So you can say that u, not u, t is equal to 2x. So we have u is equal to exponential sin u. And also we can say for that w is equal to sin u, not sin u but sin t. W is equal to sin t. So that u now is equal to exponential w. Now divide du dx will be derivative of u with respect to w, du dw, times derivative of w with respect to t, dw dt, times derivative of t with respect to x, derivative of t with respect to x. But now du dx is equal to, you differentiate this, you may differentiate exponential w, it will be made exponential w, because you are differentiating with respect to w. If you differentiate sin t, that one will be cosine t, cosine of t, dw dt will be cosine t, and if you differentiate 2x, that one will be 2 because you are differentiating with respect to x. So our result will be 2 cos t exponential w, which is equal to 2 cosine of, what is our t? T is 2x. 2x exponential w. But what is our w? Sin t. Sin t. But what is our t? Okay, maybe we can 2 cos 2x exponential sin 2x. V is equal to this one. V is equal to 2x minus 1 per a third. So we can say that t to be equal to 2x minus 1, so that dt dx, before that v is equal to t per a third, that d v dx is equal to, we're going to differentiate here v with respect to t, and here you're going to differentiate t with respect to x. If you differentiate v with respect to t here, it will be a third t to power, here you subtract 1 t to power negative 2 over 3 times, here if you differentiate you get a 2. You differentiate t with respect to x, you get a 2. So that finally you have a third. What is t? T is 2x minus 1 per negative 2 over 3. Okay, here you have these two. You have that too. So we have found dv, du. Just apply them in our formula. I'm going to create more space here. Now d y dx. What is our v? Root of that root of 2x minus 1 per a third times du dx, which is 2 cos 2x exponential sin 2x minus, here u is exponential sin 2x times dv dx, which is equal to dv dx is this 2 that 2x minus 1 negative 2 over 3 all over, you square the numerator, this will be 2x minus 1, see it was per a third, if you square that, here it will be 2 that. Part per, that is indices. Part per row, that is indices. We can factor out negative sin 2x. Here we'll be left with 2 cos x times 2x minus 1 per a third minus 2 over 3, 2x minus 1 and negative 2 over 3 all over 2x minus 1 2 over 3. So that is it. Remember to subscribe to the channel. Also, you can share the link to the videos to other engineering students, those who are taking courses in mechanical, civil, building, electrical engineering, whether diploma or certificate or a diploma, because my videos are very useful in helping students revise for their national examination.